So now we're going to use the definition we just used for the derivative to find the derivative of f of x, to find the derivative when x is 2, so f prime of 2, and the derivative when x is 0, f prime of 0. And so again, we can look at the definition of derivative, which is the limit as h approaches 0 of f of x plus h minus f of x all over h. And so again, if we want to do this in pieces, we can. So if we wanted to first look at what is f of x plus h. So we're going to go in our function, wherever we see an x, we're replacing it with that x plus h. So let's go in, put parentheses wherever we see an x. So we have an x squared, so parentheses, and then it's squared, minus, and then I see an x, so let's put parentheses there. Putting an x plus h inside the parentheses, and then let's distribute and combine like terms. So x plus h times x plus h, we have to distribute that out. Can't just square each term because there's addition in between. Minus, so this is where students need to be careful. You have to distribute this negative out here. And so that's where it's important to put parentheses around your whole f of x function, and that's actually over here. So this would give me minus x minus h. So distributing, I get x times x is x squared, x times h, so plus xh, h times x, so plus xh, and h times h is plus h squared minus x minus h. So combining like terms, only like terms we have are this x plus h times x plus h. So all together we have x squared plus 2xh plus h squared minus x minus h. Then we want to subtract off f of x. So we can start putting this together. So we're looking at f prime of x. This is equal to the limit as h approaches 0 of our f of x plus h piece, which we just found, let's just put it in there, to be x squared plus 2xh plus h squared minus x minus h. Then we're subtracting off minus this whole function. So this is where you have to put parentheses, minus around the whole thing. X squared, that quantity, x squared minus x. And then it tells us to put it all over this h. So we need to distribute that negative inside the parentheses here. And so this is equal to the limit as h approaches 0 of x squared plus 2xh plus h squared minus x minus h. Distributing that negative, I get minus x squared plus x all over h. So notice that all of our terms that don't have an h are going to cancel out here. So we have an x squared minus an x squared cancels. We have a negative x plus an x cancels. So the three terms that we're left with in the numerator is positive 2xh plus h squared minus h. So if we pull out an h, they all have an h in common. From those three terms, you'd be left with 2x plus one single h minus 1 all over h. So let's simplify. Cancel like terms in numerator denominator. Now we can take our limit. And so we're going to plug in 0 wherever we see an h. And so when we do that, we get this is equal to 2x plus 0 minus 1. Or this is equal to 2x minus 1. Okay, so that is what the derivative of our function is. So this equation, f prime of x equals 2x minus 1. This is going to give us the slope at any particular value on our function f of x, which in our case is x squared minus x. And so here, this is why it would be easier to find the derivative function first. And now we can use this when we want to find f prime of 2. So if I'm looking at f prime of 2, all I'm doing is I'm going to go in here, and wherever I see an x, I'm going to replace it with 2. And so this would give me 2 all times 2 minus 1. So this is going to give me 4 minus 1, which is 3. So what's happening is when I'm looking at the graph of f of x, that quadratic, x squared minus x, and I'm looking at what's happening at x equals 2, I notice that I have a 3 here. So my slope is 3, which means it's positive. So it tells me that that graph is positive. It's increasing when x is 2. And the rate of change at that particular value is 3. And so again, I can find out what f prime of 0 is. Same idea. I'm going to go into my function f of x, f prime of x, but this time I'm going to plug in 0 wherever I see an x. So I have this is equal to 2. I see an x, replace it with 0 minus 1. And so in this case, when x is 0, I notice that I get back a value of 2 times 0 is 0 minus 1, negative 1. This is less than 0. So I know if my slope is less than 0, my graph is decreasing there. So it's going down at that point. So let's just extend this a little more.
Professor?
Mm-hmm.
So then for f prime of x, that's just the equation, right? Because it's just x.
Yeah, so it is the equation for the derivative. So it's the equation to find the slope anywhere on our graph. Yep. So, right, so when you're looking at the derivative function with the x plus h, it's gonna be an equation. So f of x equals. Let's do this, extend this a little further because we were talking about equations of tangent lines. So let's say another part was find the equation of the tangent line. At x equals, how about negative 2 of f of x. Let's just use the same function, x squared minus x. Well, we did some of the work already. We know what the derivative function is, so we know we can find the slope at any x value you give us. And so we found that f prime of 2 was equal to 2 times x minus 1. So we want to find the slope when x is negative 2. And so, oops, that was supposed to be f of x. Let's go in and plug in negative 2 wherever we see an x. So f prime of negative 2 is equal to 2 times negative 2 minus 1. So 2 times negative 2 is negative 4 minus 1. So this is a negative 5. So f prime of negative 2 is negative 5 And what this is our slope on f of x, again, when x is -2. So I'm going to say our slope of our line is -2. We need that. And recall, in order to find the equation of a line, we needed two things. We needed a point and we needed a slope. So we have our slope. And to find our point, all we're going to do is plug in our y value, x value, into our function to find our y value. And so we need to find the point. On the line. So we're going to look at the original function, f of -2. And so going into our original function, we have a x quantity squared, so parentheses squared, minus an x, so minus a parentheses. Replacing or putting a -2 inside the parentheses. So we get back -2 quantity squared is 4, minus a negative is really plus, so plus 4, this equals 8. So I know now we have a point when x was -2, y was 8. So if you're getting help through the help feature on your homework program, they're probably showing you, my guess is, finding the equation of the line is y minus y sub 1 equals m times x minus x sub 1. You're okay if you want to do that there. I tend to, and I was doing this last week, use the point or slope intercept form, which is y equals mx plus b. And when I did this, I was like plugging in what my slope was. So -2. I was plugging in what my point was. So when x is y, my y value in this case is 8, equals my slope -2 times my x value. So when x is -2, this is -2 plus b. So I was using all the values I knew, variables I knew, just so I could figure out what b was, my y-intercept. And so doing that, I get 8 equals -2 times -2 is 4 plus b. Isolate b, we would subtract 4 on both sides. I get b equals 8 minus 4 is 4. So if b is 4, and I know my slope is -2, we know what the equation of the line is. Y equals my slope -2 times x plus 4. So this is the equation of the tangent line at x equals -2.
Professor?
Yeah.
So when you did the f of -2 on the top where it says 4 plus 4, isn't it 4 plus 2?
Yeah.
Thought I was doing my math wrong.
No, so somewhat, I have a problem sometimes because I'm trying to write and then I'm trying to think ahead. So my guess is I was already thinking to myself, -2 squared was 4. And so sometimes, thank you for catching me. I really appreciate it. So this is, so we're just going to change this a little bit. So negative and negatives, this is really +2. So actually, my point was not -2.8, it was -2.6. So let's change that to a 6. And then, so let's go back in here. We got a 6 here, 6 here, 6 here. And so really what should have been subtracting 4 on both sides, 6 minus 4 is 2. So my b value is 2. So b is 2. Let's go back in and rewrite this 4 with a 2. So that's equation of the tangent line. at x equals -2 on f of x. Any other questions or?
What did we do with the -5? The f prime of x.
F prime of x. So, what the? All right.
That really confused me.
You should be confused. Oh my goodness, guys. That should have been -5, not -2. And you guys are covered, so maybe some of your chats are saying that. So really, again, this whole thing is going to change because this m should have been -2, not -2, -5 instead of -2, -5. Let's just get rid of that. So our y value is 6 equals now our slope, which should have been -5, times our x value, which is -2 plus b. So -5 times -2, so we get 6 equals +10 plus b. So if we subtract 10 on both sides, 6 minus 10 is -4. So really our equation of the tangent line is y equals our slope, which is -5 times x plus b, and our b value is -4, so -4. Okay, anything else that I might have done wrong? No, it's really small. Okay. Any other questions? So again, it's really similar to what we were doing last week. We're just changing, instead of saying finding the instantaneous rate of change at some particular value, now we're saying find the derivative at a particular value. And then we also have that we could find the function of the derivative. So that way we can plug any value in x where the limit exists, we would get the derivative, that slope of that particular value.